Groundwater is a critical part of water resources. It provides key supplies for consumptive uses, supporting urban, industrial and agricultural development. Increasing groundwater extraction has created a wide range of impacts, not only on the aquifers themselves which are increasingly depleted, but also on dependent ecosystems such as rivers, wetlands, marshes, coastal waters which ecological conditions are highly dependent on groundwater levels.
Dry areas get drier because of climate change, and droughts contribute to warming owing to reduced cooling by evapotranspiration, which tends to enhance local heat waves.
And future climate change is projected to enhance summer drought over the entire country.
Permafrost degradations impact land usability and the quality of the water resources. Local communities built on permafrost and traditional indigenous lifestyle are therefore affected.
But very little is known about how soils and groundwater are responding to climate change and growing human influences, because most previous studies have focused on surface water.
Extraction limits are developed based on scientific studies often carried out without involving stakeholders. This top-down approach has frequently been rejected by stakeholders, generating social tensions, as well as compliance and enforcement problems.
The stakeholders' engagement is a fundamental step. In fact, the water-scarce critical zone is a socio-ecological system where the human and ecological interaction is the key driver of transformation.
The consortium carried out a 3-year project on the impact of global change on vulnerable carbon reservoirs.
The project aims at understanding how the permafrost degradation alters differently the biochemistry of hydro systems depending on the permafrost and soil settings across the Arctic.
We will consider biogeochemical cycles, water flows, and nutrient concentration discharge analyses of watersheds to determine actual and perceived effects on critical zone function in the context of land abandonment.
We will assess the impact of these changes and work with stakeholders to build future scenarios of land use.
We will pay particular attention to stakeholders' perception to facilitate a sustainable land management.
This approach also helps us identify the main knowledge gaps for a better formulation of the policy guidelines for the long-term sustainability of the water-scarce critical zones.
Addresses soil and water sustainability in landscapes undergoing management and social and cultural transitions that alter watershed properties in a way that stakeholders may not understand.
Mapping and understanding of land dynamics. And finally, estimating the ecosystem state for the next 30 to 100 years.
Our multidisciplinary approach includes geomorphology, social sciences, hydrogeology, microbiology, geochemistry, and soil sciences.
By gathering interested scientists and stakeholders from other projects to elaborate with us plausible options for groundwater and irrigation management in their own regions of expertise.
So that this place isn't just beautiful, but it's healthy, because that's really our responsibility.